Happy Friday, guys. It is a early out day. You only have, I'm trying to think, is it an hour class, right? An hour class. You got this. So I went to record these right after school on Thursday, and it was not working. So I am recording these at 9:30 at night on Thursday. I will tell you my brain has officially shut off, and I'm doing the hard problems in the ACT. So just work with me. All right, we're doing 55 through 60. This is your last day to do ACT. On this packet, I will give you more packets. I hate to disappoint you. This is not the last day of ACT. This is just the last day for this packet. So we're doing 55 through 60. If you get any of these right, honestly, I will be so impressed. Seriously. These are hard questions. In fact, I got one of these wrongs when I was going through it until I realized why I got it wrong. So 55 through 60. Seriously, if you get any of these right, come give me major bragging rights in class on Monday. All right, Seb, if you wouldn't mind, once everyone gets out their ACT packet, grabs out a pencil and a calculator if they need one. If you will pause this video, pull up a timer on Google that's a 6-minute timer. Just type in 6-minute timer on Google and start. They have 6 minutes to complete problems 55 through 60. And then when you are done with those 6 minutes, you can unpause this video and come back here. Okay, let's hop to these answers. Again, if you have no idea how to do these, you should be sticking with your letter of the day for this last bit. So if you get a bunch of these wrongs, don't be too hard on yourself. All right, 55 is E as in echo. 56 is H as in hotel. 57 is B as in Bravo. 58 is F as in Foxtrot. 59 is A as in Alpha. And 60 is K as in Kilo. All right, I was debating whether or not I would do this right now or when I get back into class. I think it would be better if I just do it now. So I want you to take, I'm going to give you a minute or two even, go through the whole thing, 1 through 60, and total up how many you got right, 1 through 60. I'm going to give you a couple minutes to do that. So 1 through 60, total up all the ones you got right. Okay. If you need to pause this, if I go too quickly as well, you can pause it to give them a little more time. But start all the way at the beginning, total up how many you got right, 1 through 60. I want you to circle that. Once you figure out how many you got right, circle that at the top of the front of your ACT. If you don't have your name there, please put your name. So put your name and then how many you got right. Okay. You can still take your time to do that. I'm just going to flip over to the page that breaks down your score while you're doing that. All right. Take your time. Feel free to pause it if people are feeling rushed. This column right here is how many you got right. So find how many you got right. And then you'll slide over here to get your ACT score on the math section, okay? So how many you got right? This would be your score. Okay? Take a second, I'll leave this up. Figure out how many you got right. This is how many you got right. This is your ACT score. Okay. I want you to circle for me how many you got right, and then I want you to write your ACT score just for this one. I just want to kind of see where you guys are at as we go through them. And if your score went up from the last one you did, I want you to write that on there for me. Tell me if your score went up. Okay? All right, again, if I'm going too fast, you can pause this and give them a little longer. I'm going to go through these questions with you guys, and then you'll have the rest of the class period to finish anything from 5.1, 5.2, or 5.3. All of those are due. 5.1 was due last week, but 5.2 and 5.3 are due Friday. Again, I'm not going to be checking anything till Monday, so if you want to just think of it as being due Monday, that's fine. But while you have this work day, there's no reason why you should wait until the weekend to get it finished. You should have it done by the time you leave class, especially since the first half of it was pretty quick, okay? All right. Last ones. 55. What is the period of the function f of x equals cosecant of 4x? This is just something you have to know. We will cover sines and cosines in a couple chapters. But sine, for example, has a period of 2 pi over b, where b is just the value right here. So does cosine. So does secant. And actually cosecant, let's do that one first. So does cosecant, and so does secant. All of those have a period of 2 pi over b. What that means is just how far from where it starts to where it ends one whole cycle. Okay? Oops. I did undo that. Oh, like that. So this is the beginning of the period, that's the end of the period. Okay? And that's how long it is. So if I'm looking at cosecant, you would just have to know, oh, it's 2 pi over b is the period. So it's 2 pi over the b value of 4. And that would simplify if I divide this by 2, divide this by 2 to just pi over 2. That's just something you're going to have to know in order to get a problem like that right. Okay? You could actually, if you tried, you could try typing that in on the calculator and graphing it. But you'd have to be familiar with how the period length works to be able to do that as well. All right, at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of the coins. What is the expected value of x? Now, I don't know that I love my answer, but essentially I said there's a possibility of getting 3 points each time, right? So he's going to toss 1 penny, 1 nickel, and 1 dime. Okay, so he could get 9 total points. Oops, sorry. There we go. And then you've got a 50% chance each time, so divided by 2. So 9 over 2. If anyone has a better explanation, I'd love to hear yours, but that's how I did it. Possibility of getting 3 points for each one, but 50% chance of actually tossing it and getting that value. Okay? All right, 57. This is actually have to do with matrices. So remember I told you matrices come up on the ACT a lot. Now, I got all excited because I'm like, oh, we've done matrices. Maybe you guys will know how to do the determinant based off what it's saying. But then the explanation of how to solve it is like way more complicated than that. So for what positive real value of k, if any, is the determinant of the matrices k, 4, 3, and k equal to k? So then it says, no, the determinant of the matrix is equals AD minus BC. We did these. I know we just did it as like an extra credit assignment and it wasn't very much time, but you're multiplying these two and then you're subtracting these two. That's what that means. So if you look at this, you're going to multiply k times k to get k squared. And then you're going to subtract 4 times 3. Okay? Now that's the determinant. It says for what positive real value of k is the determinant equal to k. And then you're going to make a quadratic out of this. I want you to notice how many times we've dealt with quadratics throughout this. And they're complicated quadratics. You're finding the determinant. You're finding you're factoring them. You're plugging them into different things. They're not easy problems, but quadratics come up a lot on the ACT. So I would move this value over here, and it's going to go right in the middle so that I have ax squared plus bx plus c. And I'm just looking for what 2 factors of negative 12 will add to negative 1. And that answer is negative 4 and positive 3. So I've got k minus 4 and k plus 3 equals 0. And it only wants, and it says for what positive value. So k equals 4 and k equals negative 3, but it wants the positive one. So that's why I get 4 for that one. Okay? Again, more complicated than it need to be, but you would do the determinant, multiply k times k is k squared minus 12, and then it wants to know when it equals k, and so I made a quadratic. All right, got a few more. Given a positive integer n such that I to the n equals 1, which of the following statements about n must be true? So this isn't something I expect you to remember right now, but it might be something that you're writing down to remember for the test. So I to the first was just I squared, it even tells you, equals negative 1. And then I cubed is just multiplying those two together, so negative I. And I to the fourth is multiplying negative 1 times negative 1, which is 1. So these repeat. And it's true for every single one. This is if you get a remainder of 1, remainder of 2, remainder of 3, and this is if you have no remainder at all. Okay, so given that information, it says, given a positive integer n such that I to the n equals 1, which of the following statements is true? Well, if I to the n equals 1, it's this situation, and that's when the remainder is 0. So if you were to take, let's say it was I to the 16, you use 16 divided by 4, and you get 4, remainder 0, then that tells you that you would equal 1. So it's going to be F. When n is divided by 4, there's no remainder. That's when you get a value of 1. Okay? The other cases, so like if I had I to the 15th, that would be 15 divided by 4. You'd end up, you can do it on the calculator, you get 3.75. That's the same thing as a remainder of 3. So remember, 0.75 was a remainder of 3. If you get 0.50, that's a remainder of 2. And 0.25, that's the same as a remainder of 1. So if I got a remainder of 3, then I would come over here and say, oh, it equals negative I, and so on. Okay? All right, 59. Again, we haven't really done trig yet, so I don't expect you to know it, but for the interval negative pi over 2 to pi over 2, when is the absolute value of sine greater than or equal to 1? This is the one I got wrong because I looked at it and I know that sine goes like this. This is pi, this would be pi over 2. This is 3 pi over 2. This is 2 pi. So that's the length of one period of pi. So if I'm looking at from negative pi over 2 to pi over 2, that's going this way. This would be negative pi over 2. So it wants to know between here and here, when does the absolute value of it equal 1? Well, I looked at it and said, oh, well, it only equals 1 at pi over 2, and I went with B. However, it said when does the absolute value of it equal 1? It equals 1 here, and it equals negative 1 at negative pi over 2. So because the absolute value of it equals 1 here, and just it equals 1 here, it's both negative pi over 2 and at pi over 2, the absolute value would be greater than or equal to 1. Okay? Last one, ray PK bisects LPM. So we've got LPM, and ray PK bisects it, means it cuts it in half exactly to 2 equal pieces. LPM, so this whole thing, its measure is 11x degrees, okay? It says, what is the measure of just this half if you know, it says the measure of LPK is 4x plus 18. What is the measure of KPM? So I'm trying to find the measure of this side. So what I did is I said, okay, if this is what one side equals, and they're equal, that means this also equals 4x plus 18. So I did 2 times 4x plus 18 is going to equal the total length, which is 11x degrees, okay? And I guess I don't really need to write the degrees when I'm solving it, okay? Then I just solved for x. So I said 2 times 4x is 8x plus 2 times 6, 18 is 36 equals 11x. I would subtract 8x from each side to get 36 equals 3x, and I will divide both sides by 3 to get 12 is equal to x. Now, again, notice that's one of the answers. That's not the right one. That is just what x equals. That's not what it asked for. It said, what is the measure of KPM? So I'm plugging 12 back in for x. 4 times 12 plus 18 would be 48 plus 18, or 66 degrees, which is the answer. Okay, so you are done with this ACT. Oops, sorry. You have the rest of the class period to finish any homework that you have missing. If you don't have anything missing, you're done with everything in my class, then you should be working on stuff in another class or sitting quietly and not distracting people that need to get work done. Okay, this is a productive work time. It's not just to talk and chat and distract and interrupt other people. Okay, so please be respectful for those that need this time to get work done. I will see you all on Monday. I hope you have a wonderful day.